The chain rule is a differentiation technique that allows us to solve problems that we haven't yet been able to do. And it doesn't take too long before we encounter something that we can't actually do using the techniques that we've got so far. This one here, for example, we could do, but it requires a pretty tedious and long expansion before we can get it into the right format. And this one here actually can't be done using just the power rule because we don't know how to expand the square root of x plus 1 to get a power rule. And it certainly is not the square root of x plus the square root of 1, in case you were thinking it was. Now, if you have a look at your information sheet, you'll see one of these two forms to describe the chain rule. F of g of x is equal to g dash of x multiplied by f dash of g of x. Or we've got dy by dx equals dy by dv multiplied by dv by dx. One of those two forms is kind of what you're given. But I reckon it's probably easier to be a bit more intuitive about it. And I didn't make up this name, but the chain rule is sometimes called the onion rule. And the onion rule basically works like this. Differentiate each layer from the inside out. And you need to think of it like an onion has a central core, then outside that core there is another layer, and then there's another layer, and then there's another layer, and that makes an onion, right? So you need to think about it the same way, and we're going to multiply those layers out. So easier to see, I think, in action. So let's have a look at it. Y equals x squared plus 1 to the power of 3. Now, the trick with these chain rule, onion rule problems is trying to figure out exactly what the inside layer and the outside layer is. So in this instance, I hope you can see we've got an expression that has been raised to the power of 3. So the expression inside is like the inner layer, and then the whole thing is the outer layer. So what we do is we differentiate the inner layer first. So that would be what is the derivative of x squared plus 1, and that would be 2x. Notice I've left a gap there. I'll explain why in a second. Then I differentiate the outside function cubed, treating the inside expression as if it's a thing, okay? A thing that we're differentiating with respect to. So we're differentiating the cube with respect to x squared plus 1, with respect to the whole thing. So we just do the same thing. We bring down the 3, and so that's what I'll do. I'll put it at the front, though, because it'll make more sense to be there. Bring down the 3, keep the thing inside the same, x squared plus 1, and subtract 1 from the power. So that's x squared plus 1 all squared. Okay, and then I'll just tidy it up. So that's 6x outside of x squared plus 1 all squared. And you will find that if you do the same thing yourself by using the power rule, that is expanding all of this first until you've got power plus power plus power plus power, and then you differentiate each of the expressions, you will find that you will get exactly that. Okay, so what I'm doing here is I'm just highlighting what those colours are. So the differentiation of x squared becomes 2x, there it is there, and then the differentiation of the whole thing to the power of 3 is found there and there, like so. And then the last one is simplification. So using the same premise, we can now solve y equals the square root of x plus 1 with a little bit of manipulation first, and then we're good to go. So the manipulation is make it y equals x plus 1 to the power of a half. And now we can sort of identify, I hope, the inside and the outside. The inside is x plus 1, like so. The outside is the whole thing. And so we differentiate the inside, and I wouldn't normally write this down, but I will for the sake of what we're doing. So dy by dx. Oops, I didn't write that on this side either, did I? It's a bit rude. dy by dx. Dy by dx is equal to differentiate the inside. That would be 1. Okay. And then differentiate the outside, and that would be x plus 1. A half minus a half is negative a half. And of course, I should have a half before it, like so. Just tidying that up. That's a half multiplied by x plus 1 to the negative a half. but to give it a gold standard finish, I'm just going to make it 1 over 2 outside of, oops, not outside of, 2 root x plus 1. And if it doesn't make sense how I went from here to here, you might need to ask in class so I can explain it to you. So there you go. Just to color code it again, we've got this whole thing here is the differentiation with respect to the inside layer, and then this little bit here is the differentiation with respect to the inside layer. Okay, a few more examples. I've color coded them as well, but I won't color code the answers anymore. I'll just do it so you can sort of see it. So we've got f of x equals x cubed minus x squared plus x plus 1 to the power of 5. Very tedious to expand that. Doable, but very tedious. But using the chain rule, I'd be going f dash of x is equal to, so we differentiate the inside first, and the inside is 3x squared minus 2x plus 1. So that's the bit in blue. And then I differentiate the outside, so I kind of fix this whole inside and then just differentiate with the power of 5. So that would be x cubed minus x squared plus x plus 1 to the power of 4, and the 5 goes on the outside, and we are done. Example 4 is silly, and I'll explain why it's silly in a second, but I wanted to show you the onion rule working on multiple levels here. So we've got one level here, then a second level here, then we've got a third level here, and we just onion it out. So f dash of x is equal to, inside layer, the red layer there, is x squared. So the derivative of x squared is 2x, multiplied by, go one layer out, x squared cubed. So that would become 3 multiplied by x squared, bring the power down by 1, squared. Multiplied by, now look at the whole thing. The whole thing is x squared all cubed to the power of 4. So the 4 comes down. The bit inside stays the same. X squared cubed to the power of 4. Now I'll simplify each term there. 2x. 3 times x squared squared is 3x to the power of 4. Multiplied by 4. And then we've got, let me see now, x squared cubed is x to the 6. 6 times, sorry, 2 3s are 6. I forgot to take my power down. Sorry, I knew there was a problem there somewhere. That should have been a cube. And then 6 times 3 is equal to 18. So I've got 4x to the power of 18. And then if I multiply the numbers together, I get 2, 3, 6, 4 to 24. And if I add the powers together on the x, we've got x to the power of 1 plus 4 plus 18 is equal to 23. So 24x to the power of 23. Or, of course, the sensible way of doing it would have been to go 2 3s are 6, 6 4s are 24. So we have f of x equals x to the power of 24. So f dash of x is equal to, bring down the power, subtract 1 from the power that was there. And of course, it gives us the same answer. If it didn't give us the same answer, then the universe would explode. So I'm glad the universe is fine. Example 5, final example. F of x equals x squared plus 1 all squared plus 1 all cubed. Again, onion rule it from the outside in. So we've got f dash of x is equal to, looking at the inside, that's the blue highlighted bit there, that's x squared plus 1. So that would be 2x. Go one more layer out. We've got x squared plus 1 to the power of 2. So that would be multiplied by 2 to the power of x squared plus 1 to the 2 minus 1, which is just 1. So it's 2 outside of x squared plus 1. Multiplied by, now we look at the full function, the green underlined function there, bring down the power, write the inside exactly as it was, and subtract 1 from the power. Simplify. Multiply the numbers together. 2 2s are 4, 3s are 12. Multiply the variables together, it's just x. And then we put our other expressions down next to it, like so. And we are done. So it's using the power rule mostly in these examples here, but the chain rule allows us to attack little bits of our problem in order to unpack it all fully. So I don't think the chain rule is that hard to do, except what I've got there in that slide 8 there. It's identifying those layers. It's about seeing that that layer 1 is x squared, layer 2 is x squared cubed, and layer 3 is x squared cubed to the power of 4. That the inside layer here is x squared plus 1, and the next layer up is the squared layer, and the next layer up is the cube layer. So when you practice these problems, what you're doing is you are practicing identifying those layers, differentiating each layer, and then with practice, you should be able to successfully use the chain rule across any number of situations.